Hello everyone, welcome to second video of the series on machine learning. In this video we are going to learn a lot about regression models, and basically the model that we are going to discuss is linear regression, right? Okay, so let's get it started. First, let's see what is regression. For example, if we want to predict something called W, right? So this is let's suppose the variable that we want to predict, which is y, and we have a intercept w naught. If you are familiar with mathematics, you will know what this intercept is. Otherwise I'll explain soon. Okay, so other than that, you have coefficients with every value of x, right? So this is w1 x1, w2 x2, then up to wnxn or wpxp, something like that. So let's suppose this is the equation, and we want to see how these data points will fit in this way. So this is what we talked about linear regression, that you have a few data points, right? And what you need to do is you need to find a line that is best fit according to your data. Let's suppose this is the data. So what linear regression does is, in fitting case, what linear regression does is it fits a linear model, right? So it fits a linear model with coefficients w1 to wn, right? And it sort of tries to minimize the sum of squares, right? So sum of squares between the observed targets in the data set. Let's suppose there is an output that we want, that is target. So it will check the sum of squares between the target that is available in our data. I'll call it target D, right? So there is a target that is available in our data like this one, right? And there is a target that is predicted with the help of our model, right? So I am going to say that is target B. It can be set as a target, it can be taken as an output, you can say whatever you want, right? So this is something that is available in the data, and this is something that we are predicting actually. So what linear regression does is it tries to solve this with the help of linear approximations, right? So when we are talking about linear approximations, then we'll have a straight line or something like that, right? And if we were to add some more things into this after that, then this will not be a linear regression. Let's suppose we multiply a p, then it will not be a linear regression, it will be changed, right? So of course we will be talking about that later. For now we are not going to talk about that. Okay, so now let's discuss how our multiple features representation change the effect of linear regression. Okay, let me see why this is not working. What is the next step? The next step is how many type of linear regression is there. There are a lot of types, and the on the basis of features, if we are talking about features, what are features? Let's suppose we have a data set like this one. So in target or output, what do we have in this data set? We have sort of diabetes values of patients, right? So these are diabetes values of patients. So we say that this is our output. What is this? This is our output. And here we say that we have a lot of features. Let's suppose one of the features is age, right? And we say that there is another feature which is called as BP, right? Blood pressure. And then we say that something like cholesterol. So there can be a lot of features like that, right? So there will be a value, if we have this data, there will be a value here, and according to all of these values we will have a target value here, right? And then there will be a value here, and a target value here. So what we do in machine learning is we actually tell it that this is our output, which is called y, and this is our input, which is called x, and we try to tell our model that this is the x value and this is the y value which is taken from that x value. So our algorithm sort of train by taking both of these values, this x and y, right? And when that training is done, there is a sort of relationship that is developed. What we talk about linear regression is it tries to approximate with the help of linear models, right? So it tries to make an assumption that both of these are linearly connected, x and y. Anyways, so the next thing is, for example, we have a value at 0.3, right? A y value, that value is 10, let's suppose, and then we have a value at 0.4, and that value is something like 11. So let's suppose we have these two values and we want to predict at 0.7, and that way if we have trained our model on this data set, it will be able to predict what will be the value of y at this 0.7, right? Okay, so what is the next thing? The next thing is number of features that we are going to use. So there are two type of linear regression. In one we use single feature. For example, we are only using BMI. So if we are only using BMI, that way we will take BMI as an input, or we can also say that it is x, and we will get an output which will be y. And in the same way we can the second type of algorithm is multiple features, right? So in multiple features, for example, we are going to take a lot of these features and we are going to make a prediction for y, right? So now let's start with taking one feature for this video, and in the next video we'll try to take up more than one feature. So let's get it started now in Python, and of course open your environment, right? I have activated it by conda-activate Saad, and then I have opened Jupyter Notebook. So now I'll open the Jupyter Notebook. If you do not know how to install Jupyter Notebook, you can go to our channel, and from there you can see how we can install Jupyter Notebooks. Now that we have covered all the theory related to linear regression, we'll actually see how we can implement it in Python with the help of sklearn. Okay, so the first thing that we need to do is we need to actually import a few libraries, the libraries that we think we are going to use in this work. So the first library that we are going to use is matplotlib. So let's write import matplotlib.pyplot as plt. Other than that, let's also import numpy. Okay, so if you do not have any of these libraries, what you can do is you can just write here pip install numpy or pip install matplotlib or something like that, right? So that will install that library into your environment. And I also have a complete course on data analysis in which I am talking about pandas, numpy and matplotlib, right? So if you go on and take that course, you will be more familiar with what numpy is, what pandas is, and what is matplotlib. A little bit of preliminary knowledge of Python and these modules is actually required when we are talking about something like machine learning. Okay, so we have imported these three libraries, and the next library that we are going to use is sklearn. So in this whole complete series we are going to use sklearn for machine learning part, right? So first I am going to get the dataset from sklearn as well, and the model that we are using is linear regression, and that model is available in linear_model. So we'll have to get this so that later we can use it to get our linear regression model. Okay, so to check out the results of our work, what we'll do is we will actually also get out the mean squared error, right, module. So what it will do is it will tell us how much of our data is resembling with each other, right, the predicted and actual values. Okay, so first let's run this. And another type of error prediction is R2 score. Let's also take that in, and we'll discuss about that when it comes. Let me give it a few more cells. So the first thing is to load the data, right? So where is the data available? So I am going to use the data from the datasets library of sklearn. So it is available in datasets dot load underscore diabetes. So diabetes is the dataset that we are going to use in this video, right? So let's see what is the data. So this is the data. As you can see, this is the data array, which can also be said as the feature array or the input array. This is the target, right? So target are all the values that were taken as an output. These are all the values, and they are also telling us that these are the feature names, right? So these are the feature names: age, sex, BMI. I have told you what features are, right? So these are the features for this data set. Okay, so these are the main three important things in this data set, right? The next thing that I am going to do is I am going to convert this into a data frame. And why is that? Why do we need to make it into a pandas data frame? The reason for that is it becomes more visualizable, right? So we will able to see what are the values more clearly. So if you do not know how to do this, I'm just going to write it. And if you want to learn more about pandas, you can just take my course on pandas that I have already uploaded on YouTube. Okay, so df is equal to pd.dataFrame, right? Here what we are going to do is we are going to tell what is the data for this data frame. So data is the part which is available in data. So actually let me change its name, right? Let's write d is equal to dataset dot load diabetes, so that you will be able to differentiate between them. So this is what is available in d, right? And here when we are telling it what is our data, then we will write our data is whatever is available in d dot data, right? So d is the name of this whole data, and data is its first row or its first sort of features, input values, right? So d is equal to d dot data, and after that we have to tell it the name of the columns. So what are the columns? The columns are these, right? Feature names are the columns. So d dot feature underscore names. Okay, it is very relatively easy if you know a little bit about pandas, right? Okay, so let's see the shape of our data frame. So this is our data frame now. It has 10 columns: age, sex, BMI, BP, S1 to S6, right? And all of these has 442 values. So there is one thing that is missing. If you can look at that, that is the target values. So let's see how we can get the target values to be represented here. Best methodology is to, of course, use this command again, right? So what I will do is I will copy that, I'll paste it, and I'll write here df, and here I'll say that the word is target, and here I'll use the column, or sorry, the data that is available in target, right? This one. And the columns, there will not be any columns because I have already told it that the column should be this one. Okay, so hopefully this works well, right? So there we go. This data is stored in target. Now what our data frame has is value against each output, right? Value of each feature against one output. So that is what we have been able to achieve. Now let's start linear regression with single feature. Okay, so the feature that we are going to take is BMI, right? This one. So we are going to take this feature as X, and we are going to take this output as Y. So let's write X is equal to, whenever you are sort of taking the input and giving it to X, always remember it should be array within an array, right? So it should be a 2D array. So when we are talking about X, we'll have to write df then double square bracket, right? Always remember that, always. And df then double square bracket, and in this I am going to write BMI. So let's see X. This is X. This is how the X should be represented, right? Array within array. Okay, so let me enter the value of Y now. So Y is equal to, what was Y? df target, right? Something like that, yeah. So df target. So let's see Y now. So this is the Y values, right? It can be like this, right? But these one cannot be. Okay, so now that we have done this, let's actually get out the linear regression model. So let's write regressor is equal to linear underscore model dot linear regression. Okay. So what it will do is, it will make sure that linear regression model is saved into REGR regressor, right? So when we are done with that, the next step is to always try to fit our data into the regressor, right? So we have talked about that before as well, right? So let's see how we can do that. We can just write REGR regressor dot fit, and here I can tell it what is the input. So what was the input? It was large X, and what was the output? It was small y. Let's get in a few more cells. So now let's run this. So there we go. It is telling us that our model has been fitted on X and Y. Now after that, what is the next step? The next step is actually predicting, right? So to perform prediction, we need to write REGR and we need to write predict with it. Now let me show you something interesting. Let's say that it is equal to y predict is equal to REGR dot predict, and where do we want to perform this prediction is the next question. So let's see X. So these are the values of X. For example, this is the value at 439, right? So to be sure about that, let's also see what is the value of Y at 439. So Y at 439 is 132, and the input for that case is 0.015906. Now what I am going to do is, I am going to take this as an input value. Again, first remember that our model has been trained with this whole data set with X as input and Y as output. The next thing that we want to do is, we want to do some prediction, right? So to do the prediction, what I am doing is, I am taking a value that is already available in the data, and I'll see that how much near to this value I get as a result, right? So for that, I'll have to copy this value. What was this? Yeah, this one. copy these value, and here in the form of 2D array, of course, as I have told you, input is always in the form of 2D array. So in the form of 2D array, I'll give it a value, right, and it will give me a prediction. Yes. So this is the simplest form of machine learning algorithm or linear regression that you can have. So the prediction that it is making is 137. Now note that we did not give it y of 439, we only gave it x of 439, and as a result what it did was it tried to predict y of 439, which looks like it's actually very much near to the real value, right? So we can actually what we can do next is we can say that this is y actual, right? So let's run this again. This is y actual, this is y predicted. Now after that there are a few things that we can represent here. The first one is coefficient of regression, right? So let's see that. So coefficient of regression, where is it available? It is always available in regr, our regressor dot coef underscore. So let's see what is the coefficient of regressor. It is 949. And after that what I actually wanted to do is I wanted to show you what is the difference between these two values, this actual value and this predicted value, with the help of something such as mean squared error. So if I want to showcase the mean squared error, right, I'll just have to write mean squared error, which is equal to percentage sign right here, after that 0.2 for 2 decimals, and then I'll write f for string. Okay, and after this, after getting out of this, I'll again enter a percentage sign, and here I'll write mean underscore squared underscore error. And what am I going to compare? Y actual, sorry, y actual with what? Y predict. Okay, so it is giving me an error. Let me see that. Okay, so what is the error? Singleton array 132 cannot be considered. Okay, yeah, that is because I have actually written y actual is equal to y of 439. However, for prediction I'll have to make this an array, right? So this is just a value. We cannot take an value, we'll take it as an array, right? Okay, so this is y actual and y predicted is already there, right? And let's do this. Yeah, there we go, we have been successful. So this is the mean square error between y actual and y predicted. Now what is the next step? As you can see, you can take any value, and on the basis of that value you can make a prediction. Those values can be other than this one as well. So what is the next step? How do we see our algorithm performance, right? For example, we have a data, right? What we do is we divide that data into two parts. So first part is train and second part is test. Now what we do here is we actually train our data on the basis of this train, right, part, and we test our data on the basis of this test part, right? And we do this division for x and y both, and later we see how our algorithm performed. So this is the actual way in which machine learning algorithms are developed. So let's do that now. So for that, the first thing I need to do is I need to write x train is equal to x of, let's say that x train is the first 70% of the values. Therefore I'll write that the last 30% should not be included. So this is x train, and what will be x test then? So x test will be equal to opposite variation, in which I'll include the last 30% of the values. So it is X train and X test. Other than that, the next thing is Y train. So I'll write that Y train is equal to, in the same way, and then minus 30, and Y. There are actually a lot of ways with the help of which you can make this X train and Y train. So if you see any other way on internet, don't be confused by it. You can use them as well, right? So there are, sklearn methodologies as well that are available. Train test validation, data set division, right? So there are a lot of methods for this. What I am trying to do is I am trying to use mathematics and trying to break it with the help of arrays. Okay, so Y test is equal to last 30% of the values. So there we go. Now that we have all of these values, what we'll try to do is we'll try to train it with the help of these 70% of the values, and we'll try to predict with the help of these 30% of values. First, let's actually check their shape one by one. So 412 values, this is X train and then X test. And the remaining values, right, from 412 to 441 are in X test, and in the same way, let's see what is Y train. So there we go, 412 values, and at last let's see what is Y test. So we have that as well, right? Okay, so now that we have this, the next step is actually trying to train our model on the basis of this. So let's make our regressor again. Regressor is equal to linear underscore model dot linear regression. Okay, and after this, let's try to fit it. So regressor dot fit, and here we'll write X train, and then what we'll do is we'll write Y train. I hope that all of this is very much clear, because I tried to get this from a very basic, right, so that anyone who actually does not have an experience with machine learning before can also learn this quite easily. Okay, so if you have been following along from the start, then you will know that now that we have been able to fit a line on X train and Y train, right? So after fitting the line, the next thing that we actually did always was try to predict. So let's try to predict by writing Y predict is equal to regr dot predict, right? And here I'll write X underscore test. So we want to make prediction on the basis of X test, and all those values will be given to Y predict, and then we will make a comparison between Y predict, which is calculated through linear regression, and Y test, which was actually the last 30% of the values. So this is how this works, right? So Y prediction is also there, right? So after this, a few things that we did was we first checked the coefficient. So let's write coefficient, and let's write regr dot coef underscore. So the coefficient is 941. After this, let's actually take this, right, and let's paste it here, and now let's change this from actual, because that was before. Now it is Y test and Y predict. So let's see what this one gives us, Y test and Y predict. Okay, so mean square error right here is 3035. Now, other than mean square error, we can actually also calculate R2 score as well. However, right now what I actually want to show you is how good of a fit our data is, right, with the respect to linear models. So for that, what I would like to do is I would like to plot a simple graph in which we will have x test and y test as data point, right, and y test and y predict as line, right. So that way we will see what were the results. Let's do that. So for that, the first thing that you need to do is you need to have a little bit knowledge about matplotlib. Of course, if you do not have, it is not that much difficult. You just remember that we have already imported matplotlib. Now let's come back and let's write plt dot scatter, right, and here let's write x underscore test, and then let's write y underscore test and take its color to be black. Okay, so there will be scattered values of x test, y test, right, according to x test and y test. Now the next thing that we need to do is we need to write plt dot plot, and here the two things that I want to do is I want to write x test and y predict. This time what I want to do is I want to write y predict, right, so that I'll know that what is the actual prediction that was made, and this thing should be in the form of a line, right. So the previous things were in the form of data points, and this thing should be in the form of a line. So let's write line width is equal to 3. Now let's write plt dot xticks and plt dot yticks. If you have any problem with any of these commands, just write them as I am doing it, and you can also look at the complete course that I have on matplotlib. That will actually help you understand better what are these graphs representing. Now let's write plt dot show, and it will show us the graph. So there we go. Our model is working not very well. It could have been better if this line would have been picked, right. I think this was a much better fit. However, this is how our model is fitting by taking BMI as an input and target as an output. So this is your first linear regression model, and after this, in the next video, what we are going to do is we are going to try and develop this linear regression model with the help of multiple features. So what is it showing? Let's see this as a conclusion. This is showing that these are all the data points that were available to us, right. So x test were all the data points that were available to us. What we did was we predicted y predict, right, and that is represented y by blue line, and both of these show us a comparison, and on the basis of this comparison we can actually see that this is the line fitting that is happening on these data points, which is actually not good enough. Hopefully when we will do something like multiple feature fitting or other things like that, it will get better. So I hope that this has been very clear to you, and to see more videos like this, and to sort of keep on learning about machine learning, keep watching this playlist and keep watching AI Studio for more information. Thank you very much.